Hey folks, welcome back. Rational expressions and equations, lesson 3, addition and subtraction of rational expressions, part 1. So remember that a rational expression is basically anything that can be written, any number that can be written as a fraction, correct? 2 over 3 is a rational number. A rational expression would be 2 over 3 plus x or something like that, or 2x plus 1 over 3 plus x. So we are going to get into adding and subtracting rational expressions, which means we're adding and subtracting. We're basically adding and subtracting fractions. Some of the rules that we need to remember when we're doing that, we need to determine the lowest common denominator. Where's my highlighter? Lowest common denominator for the rational expressions or the numbers. We need to express each rational number as an equivalent rational number with the lowest common denominator as the denominator, which means we need to convert those fractions to the common denominator if need be. Combine the rational numbers by adding and subtracting the numerators, keeping the denominator the same, and then reducing to lowest terms if possible. Okay, so that's all the process for basically adding and subtracting fractions. So as a quick refresher, add or subtract is indicated. 2 over 3 plus 2 over 5. These are not uncommon denominators, so I need to determine what my common denominator is. My common denominator is 15, so I need to make equivalent fractions for both of these on 15. And I think to myself, well, what do I need to multiply 3 by to get to 15? Well, I need to multiply by 5. So I also need to multiply the 2 by 5 as well. That's going to give me 10. What do I multiply 5 by to get to 15? 3. 2 times 3 is 6. Then I add the numerators, keeping the denominator the same. 10 plus 6 is 16 on 15. Question B, 5 over 6 minus 1 over 4. My common denominator, my lowest common denominator is 12. So I make equivalent fractions on 12. 6 times 2 is 12, so 5 times 2 is 10. 4 times 3 is 12, so 1 times 3 is 3, subtracting. So I go 10 minus 3 all over 12, which is equal to 7 over 12. And question C, 7 over 8 minus 2 over 3 plus 5 over 12. Our lowest common denominator, I think in this case is going to be 24. So it's going to be on 24, want this on 24, want this on 24. That's going to be plus, that's going to be minus. 8 times 3 is 24, so 7 times 3 is 21. 3 times 8 is 24, so 2 times 8 is 16. 12 times 2 is 24, so 5 times 2 is 10. And then I go 21 minus 16 plus 10 all over 24. 21 minus 16 is 5 plus 10 is 15 over 24. And then, of course, we need to make sure that we can, if this is reducible, both of these divide by 3, that gives me 5 over 8. Okay. Quick refresher on how to add or subtract fractions. Nothing really changes when we have variables. We just have to include those in our common denominator. So this section is basically dealing with monomial denominators. One term, one single thing denominators, not binomial stuff. I think that comes, yeah, that's going to come, well, a little bit later in this section, but definitely tomorrow, or not tomorrow, next video. So let's look at example 2. 3x over 4 plus x over 5 minus 7x over 10. My common denominator is, give you a second to think about it, 20. So I want all of these fractions on 20. Plus, minus. I multiply 4 by 5 to get 20, so 3x times 5 is 15x. I multiply 5 by 4 to get 20, so x times 4 is 4x. I multiply 10 by 2 to get 20. 7x times 2 is 14x. Now I'm going to go 15x plus 4x plus 14x all over 20 is equal to 15 and 4 is 19, 29, 33 x over 20. No, because I didn't subtract. 15 plus 4 is 19, minus 14 is going to be 5x. 5x over 20. And then 20 and 5, these reduce, 5 and 20. Okay, 5 and 20 reduce to 1 and 4. So this is x over 4. Question B, 3a minus 1 over 3 plus 4a plus 5 all over 6. My common denominator is 6, so this term does not change. But I want this on 6, so to get from 3 to 6, I multiply by 2. So I have to multiply this by 2. So I go 2 times 3a minus 1. Now I got a little bit more work to do here. 2 times 3a minus 1 plus 4a plus 5 all over 6. And I'm going to bomb the 2 in, distributive property, and then combine like terms. 6a minus 2 plus 4a plus 5 all over 6. Well, 6a and 4a is 10a. Minus 2 plus 5 is plus 3 all over 6. Now, here, no other reduction can happen. Yes, I can simplify and reduce 10 and 6 because they divide by 2, but I can't divide 3 by 2, so I can't do that. And yes, I can simplify 6 and 3 by 3, but I can't divide 10 by 3, so I can't do that either. Okay? So I have to leave it right there. Everything has to reduce by the same or you can't do anything. Question C, 8y minus 3 divided by 8 minus 2y plus 1. Now this is our first subtraction one. You're going to have to remember there's going to be an extra step here. My common denominator is going to be 24. I multiply 8 by 3 to get 24, so this is going to be 3 times 8y minus 3 minus, and I multiply 3 by 8 to get 24, so this is going to be 8 times 2y plus 1. Now I can rewrite this. It's all on 24. And let's rewrite it. 3 bracket 8y minus 3 minus 8 bracket 2y plus 1. So this minus sign, remember, when we do this bombing in, that comes with the 8. So just be aware, be careful. 3 times 8y is 24y. 3 times 3 is 9 minus 16y minus 8 all over 24. 24 minus 16 is 8y. Negative 9 and negative 8 is negative 17 all over 24. Nothing simplifies, nothing reduces, so at this point we would be complete. Moving on, question number 3, example 3. 7x plus 3 all over 2 plus 3x minus x minus 3. My common denominator is, remember, what's this 3x on? This 3x is on 1, we just never write it. My common denominator is 8. So this x minus 3 on 8 doesn't change. This has to change. This has to change. Over here, 2 times 4 is 8. So I have to multiply this by 4 as well. 4 bracket 7x plus 3. 1 times 8 is 8. So 3x also gets multiplied by 8. This is 24x. Now I can write one common denominator, and I can go 4 times 7x plus 3 plus 24x minus bracket, I'm putting this in brackets, x minus 3. You're subtracting this whole thing, so you got to throw that in a bracket. Don't put that in the bracket, you're going to end up with the incorrect answer. Now I'm going to do some bombing. I'm going to bomb the 4 in here, and I'm going to bomb this -1 in there. That's going to give me 28x plus 12 plus 24x minus x plus 3 all over 8. Combine my like terms, 28 and 24. 28 and 24 is 40, 52. Minus 1 is 51, 51x. And then 12 and 3 is 15 all over 8. And I'm done. Notice how for all of these questions so far, I've not had to worry about any non-permissible values. I don't have to worry about any non-permissible values because there's no variables in the denominator. Okay? You only have to worry about non-permissibles and those things when there's a variable in the denominator, which is coming, by the way. Question B, 4 minus y minus 4 over 9 minus 5 minus 3y all over 3. My common denominator, hope you can recognize, is going to be, well, that's on 1, is going to be 9. So this y minus 4 on 9 doesn't change. This is going to change. This is going to change. 1 times 9 is 9. So 4 times 9 is 36. 3 times 3 is 9. So 3 times all of this, 5 minus 3y. I can write one common denominator now. We're going to have 36 minus bracket y minus 4, subtracting the whole thing, minus 3 bracket 5 minus 3y. Do some bombing. I'm going to bomb in this 1 here. I'm going to bomb in the minus 3 and combine my like terms. 36 minus y plus a 4. Yeah, it's a 4. 4 minus 15 plus 9y all over 9. 36 plus 4. Actually, let's do the y's first. Okay, when we combine our y's, minus y plus 9y is 8y. And then we have 36 plus 4 is 40 minus 15 is 25. All over 9. Okay. Now, this can also be carried over. This whole idea of common denominators can be carried over with variables as well. Okay, so but now because we have variables in a denominator, we have to worry about the non-permissible values. So let's roll those out real quick, and I'll see how and you'll see how fast and how much work you really need to show for non-permissible values. X is in the denominator. It's just x. In this case, I can just very quickly say, hey, you know what? X cannot equal 0. Over here, I'm going to say 2a cannot equal 0, which simplifies to a cannot equal 0. There. Both of these are 3y minus 1. So I'm going to say 3y minus 1 cannot equal, cannot equal 0. So I'm going to add 1, divide by 3. Y cannot equal 1 over 3. And over here, x plus 3 cannot equal 0. So x plus 3 cannot equal 0. X, so no, let's show the steps. Minus 3, x cannot equal -3. Done. So when you get these factored, this is really all you need to show. Okay? All the work you need to do. And once you get used to doing it, it'll come a lot quicker. If you're not used to doing it and you need the practice, then please write out the steps. Okay? Question A. These are all on the same denominator. So I can simply say, well, they're all on the same denominator. Whoops, I'm in red now. I'm going to go 2 plus 7 minus 1. 2 plus 7 is 9, minus 1 is 8. 8 over x. Finished. I gotta go back to blue. These are both on 2a. So I'm going to go 5a plus 3 plus a minus 6 all over 2a. 5a and a is 6a. 3 minus 6 is minus 3 all over 2a. Done. There's no reduction that can take place, so we're done. And then I go to question C. These are both on 3y minus 1, so I can write one common denominator, 3y minus 1, and I can go 3y minus 1. But look, these are the same, correct? These will cancel. This just leaves me with a big old fat 1. And then our last one, 4x plus 10 minus 2x plus 4, all on x plus 3. X plus 3 is my common denominator. 4x plus 10 minus bracket 2x plus 4. I'm going to bomb that minus 1 in. 4x plus 10 minus 2x minus 4 all over x plus 3. 4x minus 2x is 2x. 10 minus 4 is 6 plus 6 all over x plus 3. And then here you'd say, hey, you know what? I'm kind of done. But isn't there a greatest common factor of 2x and 6? So I can factor out a 2. I'm going to get x plus 3 all over x plus 3. And then these cancel, leaving me with a big fat 2. That went really fast, didn't it? So when these things have common denominators already, it can go pretty fast. But chances are most of the time you're going to have to create these common denominators. Question A, example 5, question A. I think I'll do a couple of these examples because I see we got a couple of big ones still on the next page. Okay, so let's do A. We can state our non-permissible right away. P cannot equal 0 if it's just a constant or coefficient and a single variable. I can just say P cannot equal 0. They both have P, but my common denominator is actually going to be 21P. 21P. They both have P already. This one doesn't have a 7. This one doesn't have a 3. So I'm going to multiply them accordingly. So this is going to become, I multiplied 3 by 7 to get to 21. So 7 by 5 is 35. I multiply 7 by 3 to get to 21. 2 times 3 is 6. They're on the same denominator now, 21P. And I go 35 plus 6. 35 plus 6 is 41 over 21P. Let's do B, and then we'll jump to D, and then we'll move on. Question B. My non-permissible value, y cannot equal 0. So therefore I say, well, my common denominator has to have y in it. And it also has to have 3 times 5 is 15. Well, what do I multiply 3y to get 15y? I multiply by 5. So 1 times 5 is 5. What do I multiply 5y to get 15y? 3y. So 6 times 3y times 3y is 18y. All on the same denominator now. I get 5 plus 18y. Of course, in a bracket. And you're done. Well, let's skip C. If you want to see C in class, I'll happily do that in class on Zoom or something for you. But let's do D. What's our common denominator? What's our non-permissible values? This is a constant. 5a cannot equal 0, so a cannot equal 0. This is actually a constant as well. 2a squared cannot equal 0. A squared cannot equal 0. Square root of a cannot equal 0. So it's the same thing, right? So if I square root that, my common denominator is going to be has to have the biggest exponent in it, so it has to have a squared. Oops, a squared. And it has to have 2 times 5, which is 10. What do I multiply 2a squared by to get to 10a squared? I multiply by 5. So I multiply to a plus 7 by 5. What do I multiply 5a by to get to 10a squared? Straight up 2a. So 2a times 3. 3 times 2a. You know what? I'll write that the other way, just because that's the way I said it. 2a times 3. Now I can write them on the same denominator. And I go 5 bracket a plus 7 minus 2a times 3. Expand by bombing, or distributive property. 5a plus 35 minus 6a all over 10a squared. And then simplify. 35 minus a all over 10a squared. Complete. Moving on, flipping the page. Flipping the page, we have example 6. We have A, B, and C. Let's do A and C. And then I think I'll save B and example 7 for in class or on Zoom. Okay, so let's do A. First of all, it's already factored, so I'm going to do my non-permissible values. 2x cannot equal 0, divide by 2, x cannot equal 0. X minus 4 cannot equal 0. Add 4, x cannot equal 4. So my two non-permissible values, that's supposed to be an x. X cannot equal 0, x cannot equal negative 4. Not negative 4, but 4. Now, here, it's not as easy to figure out your common denominator. So now when we get into these binomial things, it's going to get a little trickier. So my common denominator is actually going to be this times this. Okay, so it's going to get pretty tricky. And I'm going to, for the first few, I'll show all of the intermediate steps. Okay, so I need to convert this first fraction to 2x on x minus 4. And I need to convert the second fraction to 2x, x minus 4. What do I multiply 2x by to get to 2x times x minus 4? Well, I multiply by x minus 4. So this is going to be x minus 9 times x minus 4. What do I multiply x minus 4 to get 2x minus 4? Well, I multiply by 2x. 3x times 2x. That's a plus sign. Okay. Now they're on the same denominator, so I can go 2x, x minus 4. Do not expand. Do not multiply these out, because eventually stuff is going to have to start canceling, and you're going to have to factor it again if you multiply it out. Do not multiply these out. Okay. Our numerators, though, well, that's a different story. X minus 9, x minus 4, plus 3x times 2x. My numerators, I do need to expand out and combine like terms. So I have two brackets here. I'm going to do my FOIL. I have these two things. I'm just going to use distributive property. X minus 9 times x minus 4 is x squared minus 4x minus 9x plus 36. And then 3x and 2x is plus 6x squared. All over 2x, x minus 4. Combining like terms, x squared and 6x is 7x squared, minus 13x, plus 36, all over 2x, x minus 4. Now, at this point, you could try and factor the numerator to see if something would cancel. But for these beginning questions, that's not going to happen. So let's not worry about it for lesson 3. But when we get into lesson 4 and further, we're going to have to start doing that. Okay. So we said we're going to do C. I'll leave this for in class if need be or wanted by students. Otherwise, we're going to move on to C. My common denominator is a combination of x minus 5 and x plus 1. So that's what my common denominator is. So I need to convert both of those fractions. First, though, I'm going to do my non-permissible values real quick. X minus 5 cannot equal 0, so x cannot equal 5. X plus 1 cannot equal 0, so x cannot equal negative 1. There you go, done. Now I need to convert both of these fractions so that they are on x plus 5, x plus 1. Sorry, not plus 5, minus 5. Minus 5, x plus 1. What did I multiply this by to get this? I multiplied by x plus 1. 2x plus 1 was already there. What do I multiply this by to get this? X minus 5. X minus 5. X minus 4 was already there by a minus sign. Now they're all on the same denominator. X minus 5, x plus 1. And I have 2x plus 1, x plus 1, minus x minus 4, x minus 5. Expand both of those brackets using FOIL. First outside, inside last. First outside, whoops. Outside, inside last. And then combine like terms. Actually, don't forget, this has got this funky minus sign here, so there's an extra step. Okay. 2x times x, 2x squared. 2x times 1, 2x. X times 1, x. 1 times 1, 1. Minus, and I'm going to put a bracket here because I'm dealing with this minus here. This minus 1. X times x is x squared. Minus 5x minus 4x plus 20. All over x minus 5, x plus 1. I need to bomb this negative 1 into this brackets. And then I'm going to combine all my like terms. 2x squared. I'm going to simplify the 2x and the x over here. Plus 3x plus 1 minus x squared plus 5x plus 4x minus 20. All over x minus 5, x plus 1. 2x squared minus x squared is x squared. 3x plus 5x plus 4x is 12x. And then plus 1 minus 20 minus 19. All over x minus 5, x plus 1. Done. So you can see how long some of these questions are going to actually take. Okay, they're going to take a fair whack of time. Question or example 7. Example 7. You know what? I'm going to say let's do example 7 just because, so that those of you that are grasping the concept won't be held back and you can move on. My non-permissible values. X plus 2 cannot equal 0. So x cannot equal negative 2. X plus 1 cannot equal 0. X cannot equal negative 1. And x cannot equal 0. 1, 2, 3 non-permissibles. Now, what's my common denominator? My common denominator is going to be all 3 of these combined because there's nothing common. So my common denominator is going to look like this. Long and messy for the first step. X plus 2, x plus 1, x. Minus x plus 2. You know what? I'm going to show you a bit of a trick that sometimes helps. What was already here? What was already here? X plus 1. What do I have to multiply in? X plus 2 and x. So over here, let's go back to the first one. 3 over x plus 2. Well, the x plus 2 is already there. So was the 3. What did I have to multiply in? X plus 1 and x. X plus 1, x. The 2 and the x plus 1 were already here. What did I have to multiply in? X plus 2 and x. X plus 2, x. Plus, x was already here. 1 was already here. I have to multiply in x plus 1 and x plus 2. X plus 1, x plus 2. Sometimes that helps. It doesn't matter to me, but sometimes it helps. Just writing it that way. Okay. Now they're all on the same denominator. X, x plus 1, x plus 2. But I have to expand each of these and then combine my like terms. So whatever process you need to go through to expand all of these, please, that's whatever steps you're going to need to show. So because I have it written this way, I'm going to say, well, I'm going to bomb this 3 in here and then do my next step. I'm going to bomb this 2 in here and then do my next step. The 1 I don't have to worry about, so I can FOIL this. So 3 times x is 3x. 3 times 1 is 1. There's 3. Don't forget, I still have to multiply x. Minus 2 times x squared, or 2 times x is 2x. Times 2 is 4. I still have to multiply by x. Over here, x times x is x squared plus 2x plus x plus 2. Now I'm going to bomb this. I'm going to bomb this. I'm going to combine like terms. 3x squared plus 3x minus, I'm going to leave a bracket here because I have my 2x squared plus 4x that I still have to multiply by a minus 1 plus x squared plus 3x plus 2 all over x, x plus 1, x plus 2. Getting there. 3x squared plus 3x minus 2x squared minus 4x plus x squared plus 3x plus 2. Whew, that is a mouthful. Okay, all over x, x plus 1, x plus 2. Combining like terms. 3x squared minus 2x squared is 1x squared plus x squared is 2x squared. 2x squared. 3x minus 4x is minus 1x plus 3x is 2x plus 2x. And my lowly constant 2 plus 2 all over x, x plus 1, x plus 2. And we are done. Now, eventually though, this may factor and cancel from top to bottom. That's technically where it's all headed, okay? So that's it for lesson, what are we on? Lesson 3. Following up on Stellantis to figure out what questions are due. We'll see you in Zoom land, and we'll see you next time.